Mathematics Subject Code 041 and 241 Classes IXX 2025-26. The syllabus in the subject of mathematics has undergone changes from time to time in accordance with growth of the subject and emerging needs of the society. The present revised syllabus has been designed in accordance with National Curriculum Framework 2005 and as per guidelines given in the focus group on teaching of mathematics, which is to meet the emerging needs of all categories of students. For motivating the teacher to relate the topics to real-life problems and other subject areas, greater emphasis has been laid on applications of various concepts. The curriculum at secondary stage primarily aims at enhancing the capacity of students to employ mathematics in solving day-to-day life problems and studying the subject as a separate discipline. It is expected that students should acquire the ability to solve problems using algebraic methods and apply the knowledge of simple trigonometry to solve problems of height and distances. Carrying out experiments with numbers and forms of geometry, framing hypotheses and verifying these with further observations form inherent part of mathematics learning at this stage. The proposed curriculum includes the study of number system, algebra, geometry, trigonometry, mensuration, statistics, graphs and coordinate geometry, etc. The teaching of mathematics should be imparted through activities which may involve the use of concrete materials, models, patterns, charts, pictures, posters, games, puzzles and experiments. Objectives. The broad objectives of teaching of mathematics at secondary stage are to help the learners to consolidate the mathematical knowledge and skills acquired at the upper primary stage, acquire knowledge and understanding, particularly by way of motivation and visualization of basic concepts, terms, principles and symbols and underlying processes and skills. Develop mastery of basic algebraic skills. Develop drawing skills. Feel the flow of reason while proving a result or solving a problem. Apply the knowledge and skills acquired to solve problems and wherever possible, by more than one method. To develop ability to think, analyze and articulate logically. To develop awareness of the need for national integration, protection of environment, observance of small family norms, removal of social barriers, elimination of gender biases. To develop necessary skills to work with modern technological devices and mathematical softwares. To develop interest in mathematics as a problem-solving tool in various fields for its beautiful structures and patterns, etc. To develop reverence and respect towards great mathematicians for their contributions to the field of mathematics. To develop interest in the subject by participating in related competitions. To acquaint students with different aspects of mathematics used in daily life. To develop an interest in students to study mathematics as a discipline. Course structure. Class, IX. Units. Unit name marks. I number systems 10. 2 ALGEBRA 20. 3 coordinate geometry 04. IV geometry 27. V mensuration 13. V statistics 06. Total 80. S. No. Content. Competencies. Explanation. Unit 1. Number systems. 1. Real numbers. 1. Review of representation of natural numbers, integers, rational numbers on the number line. Representation of terminating, non-terminating recurring decimals on the number line through successive magnification, rational numbers as recurring, terminating decimals. Operations on real numbers. 2. Examples of non-recurring, non-terminating decimals. Existence of non-rational numbers, irrational numbers, such as square root 2, square root 3 and their representation on the number line. Explaining that every real number is represented by a unique point on the number line and conversely, viz. Every point on the number line represents a unique real number. 3. Definition of north root of a real number. 4. Rationalization, with precise meaning, of real numbers of the type 1. Develops a deeper understanding of numbers, including the set of real numbers and its properties. Recognizes and appropriately uses powers and exponents. Computes powers and roots and applies them to solve problems. Differentiates rational and irrational numbers based on decimal representation. Represents rational and irrational numbers on the number line. Applies laws of exponents. 5. Recall of laws of exponents with integral powers. Rational exponents with positive real basis, to be done by particular cases, allowing learner to arrive at the general laws. Unit 2, Algebra. 1. Polynomials. 1. Definition of a polynomial in one variable, with examples and counter-examples. Coefficients of a polynomial, terms of a polynomial and zero polynomial. 2. Degree of a polynomial. 3. Constant, linear, quadratic and cubic polynomials. Monomials, binomials, trinomials. Factors and multiples. 4. Zeros of a polynomial. 5. Motivate and state the remainder theorem with examples. 6. Statement and proof of the factor theorem. Factorization of x2 plus bx plus c, a does not equal 0 where a, b and c are real numbers, and of cubic polynomials using the factor theorem. 7. Recall of algebraic expressions and identities. Learns the art of factoring polynomials. Defines polynomials in one variable. Identifies different terms and different types of polynomials. Finds zeros of a polynomial, proves factor theorem and applies the theorem to factorize polynomials. Proves and applies algebraic identities up to degree 3. 2. Linear equations in two variables. 1. Recall of linear equations in one variable. 2. Introduction to the equation in two variables. Focus on linear equations of the type x plus y plus c equals 0. Visualizes solutions of a linear equation in two variables as ordered pair of real numbers on its graph. Describes and plot a linear equation in two variables. Explain that a linear equation in two variables has infinitely many solutions and justify their being written as ordered pairs of real numbers, plotting them and showing that they lie on a line. Unit 3, Coordinate Geometry. 1. Coordinate Geometry. 1. The Cartesian plane, coordinates of a point 2. Names and terms associated with the coordinate plane, notations. Specifies locations and describes spatial relationships using coordinate geometry. Describes Cartesian plane and its associated terms and notations. Unit IV, Geometry. 1. Introduction to Euclid's Geometry. 1. History, Geometry in India and Euclid's Geometry. Euclid's method of formalizing observed phenomenon into rigorous mathematics with definitions, common, obvious notions, axioms, postulates and theorems. 2. The 5 postulates of Euclid. Equivalent versions of the 5th postulate. Showing the relationship between axiom and theorem. For example, given two distinct points, there exists one and only one line through them. Axiom B. Prove, two distinct lines cannot have more than one point in common. Theorem. Proves theorems using Euclid's axioms and postulates for triangles, quadrilaterals, and circles and applies them to solve geometric problems. Understands historical relevance of Indian and Euclidean geometry. Defines axioms, postulates, theorems with reference to Euclidean geometry. 2. Lines and angles. 1. State without proof, if a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degrees and the converse. 2. Prove, if two lines intersect, vertically opposite angles are equal. 3. State without proof, lines which are parallel to a given line are parallel. Derives proofs of mathematical statements particularly related to geometrical concepts, like parallel lines by applying axiomatic approach and solves problems using them. Visualizes, explains and applies relations between different pairs of angles on a set of parallel lines and intersecting transversal. Solves problems based on parallel lines and intersecting transversal. 3. Triangles. 1. State without proof, two triangles are congruent if any two sides and the included angle of one triangle is equal, respectively, to any two sides and the included angle of the other triangle, SAS congruence. 2. Prove two triangles are congruent if any two angles and the included side of one triangle is equal, respectively, to any two angles and the included side of the other triangle, ASA congruence. 3. State without proof, two triangles are congruent if the three sides of one triangle are equal, respectively, to three sides of the other triangle, SSS congruence. 4. State without proof, two right triangles are congruent if the hypotenuse and a side of one triangle are equal, respectively, to the hypotenuse and a side of the other triangle. RHS congruence. 5. Prove the angles opposite to equal sides of a triangle are equal. 6. State without proof, the sides opposite to equal angles of a triangle are equal. Describe relationships including congruency of two-dimensional geometrical shapes, lines, angle, triangles, to make and test conjectures and solve problems. Derives proofs of mathematical statements particularly related to geometrical concepts triangles by applying axiomatic approach and solves problems using them. Visualizes and explains congruence properties of two triangles. Applies congruency criteria to solve problems. 4. Quadrilaterals. 1. Prove the diagonal divides a parallelogram into two congruent triangles. 2. State without proof, in a parallelogram opposite sides are equal, and conversely. 3. State without proof, in a parallelogram opposite angles are equal, and conversely. Derives proofs of mathematical statements particularly related to geometrical concepts of quadrilaterals by applying axiomatic approach and solves problems using them. Visualizes and explains properties of quadrilaterals, solves problems based on properties of quadrilaterals. 4. State without proof, a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and equal. 5. State without proof, in a parallelogram, the diagonals bisect each other and conversely. 6. State without proof, in a triangle, the line segment joining the midpoints of any two sides is parallel to the third side and is half of it, and, state without proof, its converse. 5. Circles. 1. Prove equal chords of a circle subtend equal angles at the center and, state without proof, its converse. 2. State without proof, the perpendicular from the center of a circle to a chord bisects the chord and conversely, the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. 3. State without proof, equal chords of a circle, or of congruent circles, are equidistant from the center, or their respective centers, and conversely. 4. Prove the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. 5. State without proof, angles in the same segment of a circle are equal. 6. State without proof, if a line segment joining two points subtends equal angle at two other points lying on the same side of the line containing the segment, the 4 points lie on a circle. 7. State without proof, the sum of either of the pair of the opposite angles of a cyclic quadrilateral is 180 degrees and its converse. Proves theorems about the geometry of a circle, including its chords and subtended angles. Visualizes and explains properties of circles. Solves problems based on properties of circle. Unit V, MENSURATION. 1. Areas. 1. Area of a triangle using Heron's formula, without proof. Visualizes, represents, and calculates the area of a triangle using Heron's formula. States and applies Heron's formula to find area of a triangle. 2. Surface areas and volumes. 1. Surface areas and volumes of spheres, including hemispheres, and right circular cones. Visualizes and uses mathematical thinking to discover formulas to calculate surface areas and volumes of solid objects, spheres, hemispheres and right circular cones. Solves problems based on surface areas and volumes of three-dimensional shapes, spheres, hemisphere, right circular cones. Unit V, Statistics. 1. Statistics. 1. Bar graphs. 2. Histograms, with varying base lengths. 3. Frequency polygons. Draws and interprets bar graph, histogram and frequency polygon. Represents data using bar graph, histogram and frequency polygon. Mathematics question paper design. Class, IX, 2025-26. Time, 3 HRs. Max. Marks, 80. S. No. Typology of questions total. Marks. Percent weightage, approx. 1. Remembering, exhibit memory of previously learned material by recalling facts, terms, basic concepts, and answers. Understanding, demonstrate understanding of facts and ideas by organizing, comparing, translating, interpreting, giving descriptions, and stating main ideas. 43-54. 2. Applying, solve problems to new situations by applying acquired knowledge, facts, techniques and rules in a different way. 19-24. 3. Analyzing, examine and break information into parts by identifying motives or causes. Make inferences and find evidence to support generalizations. Evaluating, present and defend opinions by making judgments about information, validity of ideas, or quality of work based on a set of criteria. Creating, compile information together in a different way by combining elements in a new pattern or proposing alternative solutions. 18-22. Total 80-100. Internal assessment 20 marks. Pen paper test and multiple assessment, 5 + 5, 10 marks. Portfolio 5 marks. Lab practical, lab activities to be done from the prescribed books, 5 marks. Class, IX, 2025-26. The following topics are included in the syllabus but will be assessed only formatively to reinforce understanding without adding to summative assessments. This reduces academic stress while ensuring meaningful learning. Schools can integrate these with existing chapters as they align well. Relevant NCERT textual material is enclosed for reference. S. No. Content competencies explanation. Unit 2, Algebra. 1. Linear equations in two variables. 1. Graph of linear equations in two variables. 2. Examples, problems from real life, including problems on ratio and proportion and with algebraic and graphical solutions being done simultaneously. Visualizes solutions of a linear equation in two variables as ordered pair of real numbers on its graph. Describes and plot a linear equation in two variables. Exemplifies a linear equation in two variables and its possible solutions using real-life examples. Unit 3, Coordinate Geometry. 1. Coordinate Geometry. 1. Plotting points in the plane. Specifies locations and describes spatial relationships using coordinate geometry, e.g., plotting points in a plane. Plots, locates points in the plane. Unit IV, Geometry. 1. Lines and angles. 1. State without proof, results on corresponding angles, alternate angles, interior angles when a transversal intersects two parallel lines. 2. Prove, the sum of the angles of a triangle is 180 degrees. 3. State without proof, if a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two interior opposite angles. Derives proofs of mathematical statements particularly related to geometrical concepts, like parallel lines by applying axiomatic approach and solves problems using them. Visualizes, explains and applies relations between different pairs of angles on a set of parallel lines and intersecting transversal. Solves problems based on parallel lines and intersecting transversal. Visualizes the relation between exterior and interior angles of a triangle. 2. Triangles. 1. State without proof, triangle inequalities and relation between angle and facing side, inequalities in triangles. Derives proofs of mathematical statements particularly related to geometrical concepts in triangles by applying axiomatic approach and solves problems using them. Defines and applies triangle inequalities with reference to angles and sides. 3. Areas of parallelograms and triangles. Review concept of area, recall area of a rectangle. 1. Prove parallelograms on the same base and between the same parallels have equal area. 2. State without proof, triangles on the same base, or equal bases, and between the same parallels are equal in area. Find areas of all types of triangles by using appropriate formulae and apply them in real-life situations. Finds area of rectangle, parallelogram in triangle. 4. Circles. 1. Through examples, arrive at definition of circle and related concepts: radius, circumference, diameter, chord, arc, secant, sector, segment, subtended, angle. 2. State without proof, there is one and only one circle passing through three given non-collinear points. Proves theorems about the geometry of a circle, including its chords and subtended angles. Solves problems based on properties of circle. 5. Constructions. 1. Construction of bisectors of line segments and angles of measure 60 degrees, 90 degrees, 45 degrees, etc. Equilateral triangles. 2. Construction of a triangle given its base, sum, difference of the other two sides and one base angle. Constructs different geometrical shapes like bisectors of line segments, angles and their bisectors and triangles satisfying given constraints. Constructs line segments, bisectors of line segments, angles and triangle with given conditions. Unit V, MENSURATION. 1. Areas. 1. Application of Heron's formula in finding the area of a quadrilateral. Visualizes, represents, and calculates the area of a triangle using Heron's formula. States and applies Heron's formula to find area of a quadrilateral. 2. Surface areas and volumes. 1. Surface areas and volumes of cubes, cuboids and right circular cylinders. Visualizes and uses mathematical thinking to discover formulas to calculate surface areas and volumes of solid objects, cubes, cuboids and right circular cylinders. Solves problems based on surface areas and volumes of three-dimensional shapes, cube, cuboid and right circular cylinders. Unit V, Statistics. 1. Statistics. 1. Introduction to statistics, collection of data, presentation of data, tabular form, ungrouped, grouped data. 2. Mean, median and mode of ungrouped data. Applies measures of central tendencies such as mean, median and mode of ungrouped data. Organizes raw data in tabular form. Calculates mean, median, mode of ungrouped data. 2. Probability. 1. History. Repeated experiments and observed frequency approach to probability. Focus is on empirical probability. A large amount of time to be devoted to group and to individual activities to motivate the concept. 2. The experiments to be drawn from real life situations, and from examples used in the chapter on statistics. Applies concepts from probability to solve problems on the likelihood of everyday events. Conceptualizes probability using repeated experiments and observed frequencies. Course structure: Class 10. Units unit name marks. I number systems 06. 2 ALGEBRA 20. 3 coordinate geometry 06. IV geometry 15. V trigonometry 12. V mensuration 10. 7 statistics and probability 11. Total 80. S. No. Content competencies explanation. Unit I. Number systems. 1. Real numbers. 1. Fundamental theorem of arithmetic. Statements after reviewing work done earlier and after illustrating and motivating through examples 2. Proofs of irrationality of square root 2, square root 3, square root 5. Develops understanding of numbers, including the set of real numbers and its properties. Extends the understanding of powers, radical powers, and exponents. Applies fundamental theorem of arithmetic to solve problems related to real-life contexts. Describes fundamental theorem of arithmetic with examples. Prove algebraically the irrationality of numbers like square root 2, square root 3, square root 5, 3 plus 2 square root 5 etc. Unit 2, Algebra. 1. Polynomials. 1. Zeros of a polynomial 2. Relationship between zeros and coefficients of quadratic polynomials. Develops a relationship between algebraic and graphical methods of finding the zeros of a polynomial. Find the zeros of polynomial graphically and algebraically and verifying the relation between zeros and coefficients of quadratic polynomials. 2. Pair of linear equations in two variables. 1. Pair of linear equations in two variables and graphical method of their solution, consistency, inconsistency. 2. Algebraic conditions for number of solutions. 3. Solution of a pair of linear equations in two variables algebraically, by substitution, by elimination. Simple situational problems. Describes plotting a pair of linear equations and graphically finding the solution. Models and solves contextualized problems using equations, e.g., simultaneous linear equations in two variables. Find the solution of pair of linear equations in two variables graphically and algebraically, substitution and elimination method. 3. Quadratic equations. 1. Standard form of a quadratic equation x2 plus bx plus c equals 0, or does not equal 0. 2. Solutions of quadratic equations, only real roots, by factorization, and by using quadratic formula. Relationship between discriminant and nature of roots. 3. Situational problems based on quadratic equations related to day-to-day activities to be incorporated. Demonstrates strategies of finding roots and determining the nature of roots of a quadratic equation. Solves quadratic equations using factorization and quadratic formula. Determines the nature of roots using discriminant formulates and solves problems based on real-life context. 4. Arithmetic progressions. 1. Motivation for studying arithmetic progression. 2. Derivation of the nth term and sum of the first n terms of AP and their application in solving daily life problems. Develops strategies to apply the concept of AP to daily life situations. Applies concepts of AP to find the nth term and sum of n terms. Application of AP in real life problems. Unit 3, Coordinate Geometry. 1. Coordinate Geometry. 1. Review. Concepts of coordinate geometry. Distance formula. Section formula, internal division. Derives formulae to establish relations for geometrical shapes in the context of a coordinate plane, such as finding the distance between two given points, to determine the coordinates of a point between any two given points. Solves problems using distance formula and section formula. Unit IV, Geometry. 1. Triangles. Definitions, examples, counter-examples of similar triangles. 1. Prove, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. 2. State without proof, if a line divides two sides of a triangle in the same ratio, the line is parallel to the third side. 3. State without proof, if in two triangles, the corresponding angles are equal, their corresponding sides are proportional and the triangles are similar. 4. State without proof, if the corresponding sides of two triangles are proportional, their corresponding angles are equal and the two triangles are similar. 5. State without proof, if one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, the two triangles are similar. Works out ways to differentiate between congruent and similar figures. Establishes properties for similarity of two triangles logically using different geometric criteria established earlier such as basic proportionality theorem, etc. Prove basic proportionality theorem and applying the theorem and its converse in solving questions. Prove similarity of triangles using different similarity criteria to circles. Tangent to a circle at point of contact. 1. Prove the tangent at any point of a circle is perpendicular to the radius through the point of contact. 2. Prove the lengths of tangents drawn from an external point to a circle are equal. Derives proofs of theorems related to the tangents of circles. Prove the theorems based on the tangent to a circle. Applies the concept of tangents of circle to solve various problems. Unit V, Trigonometry. 1. Introduction to Trigonometry. 1. Trigonometric ratios of an acute angle of a right-angled triangle. Proof of their existence, well defined. 2. Motivate the ratios whichever are defined at 0 degrees and 90 degrees. Values of the trigonometric ratios of 30 degrees, 45 degrees and 60 degrees. 3. Relationships between the ratios. Understands the definitions of the basic trigonometric functions, including the introduction of the sine and cosine functions. Evaluates trigonometric ratios, describes trigonometric ratios of standard angles and solving related expressions. 2. Trigonometric identities. 1. Proof and applications of the identity sin 2a plus cos 2a equals 1. 2. Only simple identities to be given. Uses trigonometric identities to solve problems. Proves trigonometric identities using sin 2a plus cos 2a equals 1 and other identities. 3. Heights and distances. Angle of elevation, angle of depression. 1. Simple problems on heights and distances. Problems should not involve more than two right triangles. Angles of elevation, depression should be only 30 degrees, 45 degrees, and 60 degrees. Applies trigonometric ratios in solving problems in daily life contexts like finding heights of different structures or distance from them. Find heights and distances in real-life word problems using trigonometric ratios. Unit V, MENSURATION. 1. Areas related to circles. 1. Area of sectors and segments of a circle. 2. Problems based on areas and perimeter, circumference of the above said plane figures. In calculating area of segment of a circle, problems should be restricted to central angle of 60 degrees, 90 degrees and 120 degrees only. Derives and uses formulae to calculate areas of plane figures. Visualizes and evaluates areas of sector and segment of a circle. 2. Surface areas and volumes. 1. Surface areas and volumes of combinations of any two of the following: cubes, cuboids, spheres, hemispheres and right circular cylinders, cones. Visualizes and uses mathematical thinking to discover formulae to calculate surface areas and volumes of solid objects, cubes, cuboids, spheres, hemispheres, right circular cylinders, cones, and their combinations. Evaluates the surface areas and volumes of combinations of solids by visualization. Unit 7, Statistics and Probability. 1. Statistics. 1. Mean, Median and mode of grouped data, bimodal situation to be avoided. Calculates mean, median and mode for different sets of data related with real-life contexts. Computes the mean of a grouped frequency distribution using direct, assumed mean and step deviation method. Computes the median and mode of grouped frequency distribution by algebraic method. 2. Probability. 1. Classical definition of probability. 2. Simple problems on finding the probability of an event. Applies concepts from probability to solve problems on the likelihood of everyday events. Determines the probabilities in simple real-life problems. Mathematics Standard Code 041. Question paper design. Class X 2025-26. Time 3 hours max. Marks 80. S. No. Typology of questions total. Marks. Percent weightage, approx. 1. Remembering. Exhibit memory of previously learned material by recalling facts, terms, basic concepts, and answers. Understanding. Demonstrate understanding of facts and ideas by organizing, comparing, translating, interpreting, giving descriptions, and stating main ideas. 43-54. 2. Applying. Solve problems to new situations by applying acquired knowledge, facts, techniques and rules in a different way. 19-24. 3. Analyzing. Examine and break information into parts by identifying motives or causes. Make inferences and find evidence to support generalizations. Evaluating. Present and defend opinions by making judgments about information, validity of ideas, or quality of work based on a set of criteria. Creating. Compile information together in a different way by combining elements in a new pattern or proposing alternative solutions. 18-22. Total 80-100. Internal assessment 20 marks, pen paper test and multiple assessment 5+5, 10 marks, portfolio 5 marks, lab practical, lab activities to be done from the prescribed books 5 marks, mathematics basic code 241. Question paper design. Class X 2025-26. Time 3 hours max. Marks 80. S. No. Typology of questions total. Marks. Percent weightage, approx. 1. Remembering. Exhibit memory of previously learned material by recalling facts, terms, basic concepts, and answers. Understanding. Demonstrate understanding of facts and ideas by organizing, comparing, translating, interpreting, giving descriptions, and stating main ideas. 60-75. 2. Applying. Solve problems to new situations by applying acquired knowledge, facts, techniques and rules in a different way. 12-15. 3. Analyzing. Examine and break information into parts by identifying motives or causes. Make inferences and find evidence to support generalizations. Evaluating. Present and defend opinions by making judgments about information, validity of ideas, or quality of work based on a set of criteria. Creating. Compile information together in a different way by combining elements in a new pattern or proposing alternative solutions. 8-10. Total 80-100. Internal assessment 20 marks. Pen paper test and multiple assessment 5+5, 10 marks, portfolio 5 marks. Lab practical, lab activities to be done from the prescribed books 5 marks, prescribed books. 1. Mathematics, textbook for class 9, NCERT publication. 2. Mathematics, textbook for class 10, NCERT publication 3. Guidelines for Mathematics Laboratory in Schools, Class 9, CBSE Publication 4. Guidelines for Mathematics Laboratory in Schools, Class 10, CBSE Publication 5. Laboratory Manual, Mathematics, Secondary Stage, NCERT Publication 6. Mathematics Exemplar Problems for Class 9, NCERT Publication 7. Mathematics Exemplar Problems for Class 10, NCERT Publication.